Hello everyone, so today we'll be integrating this question x to the power 4 minus 1, of course dx. So the way we solve this question is also changing it into partial fraction, but before that let's just apply the formula of a square minus b square. So this term can be written as this, and then this can be considered as a square minus b square, so it is a minus b, a plus b. So the changed format would be this, and I hope you understand how this came. So these two terms make up for x square minus 1, and we just expanded them in order to make it three terms. So now it's just simply changing it into partial fraction. For now, let's just forget that we have the integration sign. Let's just change this part into partial fraction. So is equal to a over x minus 1 plus b over x plus 1 plus for this one, you know how to change it into partial fraction. If there is x squared, then we have x in the numerator as well, cx plus d over x squared plus 1. So if we are to equate this term without the integration sign, of course, we are just converting it into partial fraction. And this term, then what we will get is 1 is equal to a multiplied 1 plus x square plus 1 plus b multiplies x minus 1 x square plus 1, then cx plus d multiplies these two terms that can be written as x square minus 1. So for this we can just equate the coefficient by multiplying everything with each other, but then before that let's try and find the value of a and b. For that we don't have to equate the coefficients. If we consider x to be minus 1, then over here minus 1 plus 1 cancel each other out. Minus 1 whole square would be 1 itself, so it would be 2 over here, but then since this is 0, the entire term containing a cancels out, and then over here in b, minus 1 would be minus 2, and this 2 would again be 2, so that way we will get b as minus 1 over 4. This term 2 gets cancelled, so we'll get b as minus 1 over 4, and if we are to keep a as, oh no, sorry, x as 1, then we will find the value of a as well. That would be 1 over 4. So yes, we have the value of b. Let's change the color. We have the value of a. So now let's try and find the value of c and d. For that, it's the best if we just equate the coefficients, multiply things over here. So before that, let's just make our working space, the whiteboard, cleaner. Yep, this too is not needed. Let's just zoom in to remove these. Yep, so let's move to the next page, where I'll write you the equations that you will be getting by equating the coefficients. So if you equate the coefficients of x to the power 0, that is 1, then you will be having 1 is equal to a minus b minus d. You know the value of a, you know the value of b, you can find the value of d. The value of d from this would be minus 1 over 2. So you have another value as well. And then the next value that you would need is of c. So again, equating coefficient of, I think, x square, you would get a plus b plus c, or I think it's x cube. Yeah, equating the coefficient of that, you know the value of b, you know the value of b. So the value of c from this one would be 0, because these a and b cancel each other out, so c has to be 0. And now it's just simple integration. So let's integrate. What is a? It's 1 over 4. So since it is constant, it gets removed. 1 over 4 integrating 1 over x minus 1 dx, minus 1 over 4 integrating 1 over x plus 1 dx, and then minus 1 over 2. C is 0, so it makes no difference. Let's look over here. C is 0, so d is minus 1 over 2. So minus 1 over 2 integration 1 over x square plus 1. 1 can be written as 1 square as well. And you will understand the reason why I'm representing 1 as 1 square. So yes, let's go over here. So the answer for this will be coming in logarithm form, this as well in logarithm form, and this in the form of tan inverse. And so 1 over 4, I'm going to skip one step to see if you guys remember it. So here we will get log x minus 1 minus log x plus 1, taking 1 over 4 common. So log a minus log b can also be written as log a over b. So that's what I've done here, minus 1 over 2 times the formula that I've also discussed in my previous videos for uh, 1 over x square plus a square is uh, tan inverse x over a. So over here a is 1, so this can simply be written as tan inverse x over 1, so over 1 is not needed, plus the integration constant. So there you go. This is the final answer for this question. It's not very difficult. You just have to learn how to represent it into partial fractions, and there you go. Thank you for joining with me on this one. I hope you learned how to do this, and hope to see you in my next videos. Thank you.